Hi everybody. The next we are going to discuss about the microcontroller, that is the register organization. That is very important of each and every registers. So temporary memories. The register organization is refers to the arrangement, structure, and management of register within the micro. That's the main functions of register organization. We have to arrange and structure management. Those are the main functions of registers, mainly within the microcontroller. That's the main agenda. And after small and high-speed microcontroller locations within the CPU, that central processing unit, or other processing unit, that the stored data is temporarily during the program execution is held, controlled, and stats of information, and facilitate the common between the different ports of the system. That's the main function of registers. It may be small or it may be very speed. So the location of the central processing unit want to transfer and a processing unit in the store the data, that's temporarily by using the execution time. So the information is very facilitate the common difference between the port and the systems. That's the main important register of the organizations. The data pointer, that's a DTPR, mainly the 16-bit register. It consists of that's a DPH, that is direct, and then the load byte, that's a DPL. That's a data pointer higher byte, and a data pointer lower byte, that's the main DTPR. And also it has the 16-bit registers, and it used to hold the external data as memory address, like the data being is fetched with the use of hold and external memory. And the program counter, mainly it's a 16-bit. Both the DTPR and the program counter are the same bit registers, and its hold address is instruction set by using the currently fetched, and increments continuously to the point to the next instruction set. Maybe after fetching the instruction from the memory, the program counter is automatically incremented to the point of the next memory location. It will be subsequent instruction started. That's the main difference between that DTPR and PC. That's the data pointer and the program counter. So the special functions and registers are accumulator, that is A having the 8-bit register and the B registers. It is used for the data transfer and arithmetic operations after the any operation results are shown in the A-bit register, that accumulator, because everything is executed and temporary is shown in the operation of the A-bit register, that's accumulator. And the B registers is used for the store upper 8-bit results, the multiplications, divisions, and used for the temporary register, that's the B accumulator or B registers we are using here. And mainly the register organization, there's a PSW, that is a program stats var, is used for the special function for the register, and consists of the different stats between the reflex and the current state of microcontroller. Mainly the contain the carry, the Shiva and auxiliary carry, that's AC of and F values for the defined bits of flag. It can be used in the store or any data. The data registered by bank, the select that RS1 and RS0 is mainly the maybe of bits of the program status way, and also the overflow block, that is the OV, is used here. And mainly the parity bit, that 2, that's a parity bit, that 0 or 1 we can use in that parity bit of value indicates as a P. That's a define of statistic flag we are mainly using. That's a CY, AC, F0, RS1, RS0, 0V, and a V feature function and a P. These are all the program status word, that's PSW, are used here for the register purpose. Another thing, that's the stack pointer, that's SP, is another one. It is a 8-bit register and can be, it is incremented before the data is stored onto the stack. That is the previous one, that's a 8-bit register. We use it in the incremented format, that's a plus plus, and also the push call instruction of execution is mainly used in the stack point, that's SP. And also the during the push and the first SP incremented in the copy data, that's the pop operations, mainly the initially the copy of the data, then the decrement of the SP values here. And the second thing, mainly the pick on, that's a power control unit, is the SFR used in the control of 8051. This is the power control modes. And certain operations modes of the 8051s allow going to the sleep mode, which requires much less power consumption. Whenever it is made, it will be turn on and on. Other remaining time it will be in the sleep mode. So automatically the power consumption will be take this here. And also the mode of operation are controlled by through the PCON, that is the power control unit mainly here. Another thing is TCON, that's a timer control bit addressable. Mainly we can use SFR, use of the configurable modification way, which will be the 89051 timers operate. Mainly the SFR control whether each two timers are running or stopped in the container of the flag indicate the each and every timer is overflow. And the time mode, that is a timer mode, the SFR used in the configure of mode operation each and every two timers. Each timer has a 16-bit timer and 8-bit auto-rotated timer. That's mainly in the 13-bit timer we can use for the separate operation functions. The TLO, TLH are mainly used, that is a timer low and high we can use for the SFR function to represent the timer. And TL1, TLH is nothing but the low and high. Those of SFR token we can use for the representation of timer 1. And the SCON, SF, that is a serial control, that's a serial control, the SFR user the configure behavior of 1851, there's onboard of serial port. Those the SFR controls the baud rate on the serial port, whether the SSL, the serial port are activated to the receive data, and also the content the flags of set to be within this is successfully sent or received. Mainly we are using that's a serial control unit, mainly serial before SFR. Again, then send receive the data via onboard the serial port, and any values returned in the buffer values in the serial port. Mainly the likewise any value which is 8051 received via serial ports, and other delighted programs we can use. That's IE and IP, that is interpretable and interpriority we can use for the another application purposes. Thank you.